how is this described in decibel notation? Okay, so if something has an increased by a factor of 100, again, guys, we can just, because it's in the power of 10 already, we can just count the number of zeros, right? Okay, so we know that 100 equals 10 times 10. It's a logarithmic scale based on the power of the 10, right? That's what a logarithmic scale is. It's based on the power of the 10. 10 times in decibel notation, again, is going to be plus 10 decibels, right? So if something increased 10 times itself, then that's going to be plus 10 decibels, or just 10 decibels increase. All right? Therefore, the decibel notation used for 100 is going to be plus 10 decibels, and then you add another 10 decibels, which is going to equal 20 decibels, right? So 100 factor increase is going to equal to 20 decibels. Okay? So that also saying that a factor increasing by 10,000 would be 40 decibels, right? Because I'm really just trying to make it simple. 4 zeros in 10,000 is gonna be equivalent to 40 decibels. Okay? It's really easy when you have numbers that are exact or by power of 10. All right, which is what I'm probably going to keep it as. I'm probably going to keep it, if I ask the question in that way, it's probably just going to keep it at power of 10. But if I actually have an intensity change, like if I have an intensity, like, let's see, like number 8, look on page 79. A wave's intensity is 2 milliwatts per centimeter squared. Okay? That's what intensity is. That's in form of intensity. Because remember, intensity is power over area. Correct? All right? There is a change of plus 9 decibels. What is the initial intensity? So plus 9 decibels. I'm sorry, what is the final intensity? So plus 9 decibels, if we start at 3, we know that 3 means it's double. 6 means 2 times 2, it quadrupled. 9 means 2 times 2 times 2. That's going to mean it's going to increase by 8-fold. Okay? So we can take our initial intensity, which is 2 milliwatts, and multiply that by 8. Correct? Right?
Can you work that out?
Yeah.
Okay. All right. So, ratio. So I'm going to write 3, 6. Remember, decibels as far as sound intensity or acoustic intensity is going to be about by increments of 3. Okay. So and 9. So that's our next number. That's 12 decibels. Somebody. So that means it's going to double. So we're going to have to take 2 times 2. I'm sorry. It's going to be the number 2 because it just doubled, correct? All right. So increase 3 more increments. It's going to be 2 times 2. That equals 4. That means it's going to increase. It's going to quadruple in intensity. Okay. Then add another 3 decibels. So it's going to be 2 times 2 times 2. That's going to equal 8, correct? All right. So the question is asking us, a wave's intensity is 2 milliwatts per centimeter squared. There's a change of 9 decibels. Okay? We know a change of 9 decibels, meaning that that number, whatever the initial intensity, is going to increase 8-fold if we're looking for that final intensity. Correct? All right. So it's asking us, what is the final intensity? Okay? So we can take our initial intensity times 8 because that's how many times it increased, correct? So initial intensity is 2 milliwatts per centimeter squared times 8. That's going to equal 16
1 milliwatt over
milliwatts per centimeter squared. That's how we get that answer right there. So that's like saying if let's take our original number, let's say it decreased let's say that's our initial intensity and our beam attenuated 9 decibels. All right. So, so if it attenuated, we know that that's a negative number, right? So -9 in attenuation. That's how much it's gonna. So we have to multiply it by the reciprocal, right? So that's gonna be 1/8, 1/4, and by half. Right? Okay. We're good there? If you're not good, we have our little cheat sheet here. Yeah, I'm giving you another example in the opposite way right now. So in this case, our initial intensity would be 2, and it attenuated by 9 decibels. Our ultrasound, our wave intensity attenuated by 9 decibels, which is equal to, is going to attenuate by 1/8, correct? So that's going to be times 1/8. So guys, 2/1 times 1/8 equals
1/4.
2/8 equals 1/4
0.25.
equals our
25.
final intensity is going to equal 0.25 milliwatts per centimeter squared. I hate writing at these angles. And if you just think about it, our initial intensity was 2 milliwatts. If we just divide 2 milliwatts by 8, we're going to get 1/4 of 0.25, correct? So that's how you can work it both with attenuation and by the example it gave you in the book.
So it's not -1/8, it's just 1.
Just 1/8. It's going to attenuate by 1/8. The decibel will be negative. Decibel will be negative. Okay. Whenever I talk about attenuation, I'm talking about negative decibels, because attenuation means weakening or losing energy. Okay. Do I need to make some piles up for you guys to take home with? Okay. So there probably will be math like this on the exam.
It will be or not?
It will be. Okay. So I'll make you guys look like 5 problems. Look for it on the app. What's our app?
Remind.
Look for it on Remind later.
Yeah.
Okay. Are we good on these examples, Myra?
Yeah. So what's the way to find out
The acoustic power?
Yeah.
That's why we're doing it by increments of 3.
But so you don't have to write at 2
because you already know that 3 means it doubled, right? Or -3 decibels mean it halved. So you always gonna take whatever, like I said, it's gonna increase by increments of 3 or decrease by increments of 3. So you're just gonna take whatever that is. You have to multiply that number by 2. By 2. By 2 is the operative number. 12?
You have a decimal of 12.
No, 8 times 2 is 16.
Where did you get 12 from?
Right here on the decimal.
You have to put it up and down.
But look, the question is actually telling you it increased by 9 decibels. Are you in the book?
Yeah, but I'm just, it was like a shortcut to figure out this X number. So you don't have to multiply.
I don't have a shortcut for that. I don't have a
So you would
shortcut.
always have to use.
Definitely. That's why I gave you that. That's exactly why I gave you that. So you don't have to put it to memory. If you want to just write something like this down on your test. I haven't figured that out yet. Let me say that. I haven't figured that out yet. I haven't figured out a shortcut for that number.
So if you have the 30, you have to do 2 times 2 times.
No, because we already have our larger scale of decibel conversion. We know that 30 is going to add 3 zeros, and that's going to be 1,000.
No,
Intensity.
30, that's 36.
36. So yeah, that's going to be 1,024. That's 2048 times 2 is, what's that? 2048 times 2. What's that, guys? Somebody got to calculate. 2048. That's 4,000. 2048. 4,096. 4,096. 2048 times 2.
48 times 2.
40. That's one point. But chances are, I'm not going to ask you what's it increased by 36 decibels. I'm probably just going to say it increased by 40 decibels. You know, so I'm just giving you once you get to like 30, that's where the numbers start, you know, not matching up. So let's take for example our 20 decibels, right? Look on your page right here. It actually doesn't have a remember a decibel change of 20 will be 100 times greater, right? And increase by 100. We don't have it. Golly, we don't have it right here. But
Where you have it?
on the chart right here, like how you can figure that number is we have 18 and 21. And so you can see that it's relative. 18 decibels would be 64, right? 18 decibels was 64. 21 would be 128. So somewhere in between there would be 20, which is equivalent to about a 100 decibel change. Okay. A change of intensity of 100. Okay. You guys? No, I hate to make it so, you know, in depth.
So wait, sorry. The number is 20.
I'll give you 20, then we're going to go with the relative number of 100. And increase approximately 100.
Can you work it out together? Can you work it out?
Nah, I'm not even going to go down. Like I said, take what I'm giving you. Don't take it deeper than that. I'm taking it as deep as I want to take it because I know you guys want answers. I know you guys. You guys are not just going to be like, okay, it's 1,028. Okay, I can deal with that. Y'all don't like that. Y'all want to know why. So this is my long explanation as to why this is the case.
So is it 12 decibel is 2 times 2 times 2 times 2 like
4 times 2 times 2 times 2 times 2.
So it's equal 16.
16. So you see, I skipped numbers. I jumped straight from 9
to 12.
So if it would have been 12, it would have been right here. 16 between. 16 would have been between here and the 20.
Because I can figure out how to do that by Physic 912, but 10 I cannot figure it out.
Exactly. That's why they give you in increments of 10, because again, when they're in these larger numbers, they're measuring actual volume loudness. So when they're measuring like say for instance, when you buy a vacuum cleaner, it may say this device, Mr. C, you're talking too loud. They may say this device is 20 decibels, 20 decibels quieter than this Hoover vacuum cleaner. I don't know if y'all ever noticed that, you know, your stuff has decibels on it. So that's like saying that 20 decibels, that's like saying that it's 100 times quieter than the Hoover vacuum cleaner. Okay? No? Okay. Muscle members?
Can I show you real quick how I figure out this? I just want to make sure.
You guys are trying to apply math to it. It's not an absolute number. You can't apply math to every single thing. It's a relative number. It's a relative intensity. All right, there you go. You want to do it like that? That's, again, guys, if that's how you want to do it, that only confuses the situation more. You just added more and more layers to it.
This number
that don't necessarily have to be added.
That's how I figure out.
Erase that. I wouldn't do that. I wouldn't do that. You just added more stuff to it.
New math style.
Exactly. You just added more to it when you can just accept the raw numbers that are given. Accept the raw numbers that are given, because it's not an absolute number. It's not absolute. Okay, it's relative. It's an approximate degree of amplification or attenuation. All right? So there's no specific formula as to why can't I work out what's a 1 decibel change. You know what I mean? It's not an exact number. All right? But if that helps you remember, then use that. Use that.
So you just memorize it?
I would, definitely. Definitely. Just know that when you're doing it by increments of 3, it's 2 times whatever, you know, whatever you're going up by 3, whatever the increment of 3 is. that's how I would do that. Again, nobody's gonna ask you what is a 72 decibel change. You know what I mean? They're probably gonna say what is a 70 decibel change, which is